Now let us study about properties of Laplace transform. The first property is called as a shifting property or shift property. This says that if Laplace transform of a function is f of s, capital F of s, then Laplace transform of that function multiplied with e power at is f of s minus a. Means in the Laplace transform of this function, you have to replace s by s minus a. Let us take one example. See, Laplace transform of e to the power t into t square. Okay. First, let us find out here f of t equal to t square, correct? No. And e power at is e power t, a equal to 1 now. First, you have to get Laplace transform of f of t. What is Laplace transform of f of t? That is Laplace transform of t square. Here, 2 is a positive integer. Therefore, 2 by s cube. This is your f of s. Now, you got f of s. Now, to get Laplace transform of e power at f of t, you have to replace s by s minus a in this function. So you will get 2 divided by s minus a is 1, s minus 1 whole cube. This is using the shift property of Laplace transform. Now take up one more example. Laplace transform of this function. Here f of t equal to 2 cos 5t minus sin 5t. We need the Laplace transform of f of t. That is Laplace transform of this function. 2 into what is Laplace transform of cos 5t, which is s by s square plus 5 square is 25, minus here Laplace transform of sin 5t, 5 divided by s square plus 5 square is 25. You can simplify this as 2s minus 5 divided by s square plus 25. Now this function, this whole function is multiplied with e power minus 2t. Therefore, here a value equal to minus 2. A is minus 2. You have to replace s by s minus a in the function f of s. This is your f of s now. Therefore, this is equal to Laplace transform is equal to, so 2 into s you have. So s minus of minus plus s plus 2 minus 5 divided by s plus 2 whole square plus 25. So this gives you 2s plus 4 minus 1 minus, see, plus 4 minus 5 minus 1 by s square plus 2 to the 4s plus 29. So this is the final answer. You can split it and you can apply this property to individual terms, or else take this as f of t and find its Laplace transform. Then in the function f of s, you have to replace s by s minus a. Now see the second property of Laplace transform. If Laplace transform of a function is f of s, then if that function is multiplied by t to the power n, then its Laplace transform is given by minus 1 power n into d nth derivative of f of s. Sometimes this is also called as derivative property of Laplace transform, where here n is positive integer. That is the condition. See, for example, take Laplace transform of, find Laplace transform of t into sin t. So here f of t equal to sin t and n equal to 1, t to the power 1 now. Therefore, first let us find out Laplace transform of f of t. What is Laplace transform of sin t? Sin 1t, it is 1 by s square plus 1 square is 1. This is equal to f of s. So as per this property, this is minus 1 to the power 1 into d by ds of f of s. You have to find out first derivative of f of s. So the minus 1 power 1 is minus 1 into, what is derivative of 1 by s square plus 1? Derivative of 1 by x is minus 1 by x square. Apply the same property, then apply the chain rule. So it is minus 1 by s square plus 1 whole square, then into derivative of s square plus 1, that is 2s. Therefore, finally we will get 2s divided by s square plus 1 whole square. This is the value of a Laplace transform of t into sine t using this property. Now take up one more example. You have to find Laplace transform of t power 5 into e power 4t. See here you can apply either this property or the previous shift property also. So let us apply this property first. So here f of t equal to e to the power 4t and n equal to 5. What is Laplace transform of f of t? Which is equal to 1 by s minus 4. Okay, this is your f of s. Now as per this property, minus 1 to the power 5 into d5 by ds to the power 5 into f of s. You need to find out a fifth derivative. You have to go till fifth derivative of this function f of s. So f dash of s is equal to derivative 1 by x is minus 1 by x square. So same way, minus 1 by s minus 4 whole square, derivative of s is 1. So this is first derivative. F double dash of s is equal to, so it is 2 by s minus 4 whole cube. Okay, then f triple dash of s is equal to minus 6 by s minus 4 whole power 4. Then f fourth derivative s is equal to minus 24 minus of minus plus 24 divided by s minus 4 to the power 5. Then fifth derivative it is equal to, it is minus 120 divided by s minus 4 to the power 6. So we got the fifth derivative as this. Let us substitute that here. This is minus 1 into minus 1 power 5 is minus. So minus 120 divided by s minus 4 to the power 6. So that gives you 120 divided by s minus 4 to the power 6. This is the required answer as per this second property. See, if you apply the first property, Laplace transform of e power at into f of t is equal to f of s minus a. So in that case, you have to take f as a t power 5. F of t equal to t power 5. What is Laplace transform of f of t? This equal to 5 factorial, means 120 divided by s to the power 5 plus 1 6. So then this is your f of s. So replace s by s minus a. What is the value of a? Here a equal to power of exponential, that is a coefficient 4. So 120 divided by, replace s by s minus 4, s minus 4 to the power 6. This gives you the answer easily as well as quickly. So you can apply any one of the property for this example. Now see the third property. If Laplace transform of f of t is f of s, then Laplace transform of f of t divided by t. There in the previous case you had multiplied by t. Here divided by t. It was multiplied by t power n. Here just divided by t to the power 1, which is given as integral from s to infinity f of s into ds. It involves the integral. See for example sin at by t. You have to find the Laplace transform of this function. You have to make use of this property. So first, what is f of t here? This is sin at. So Laplace transform of sin at equal to a divided by s square plus a square. This is your f of s. As per this property, integral from s to infinity, f of s is a by s square plus a square into ds with respect to s. So a is a constant. What is integral of 1 by a square plus x square? Tan inverse of x by a. 1 by a into tan inverse of x by a. So this gives you 1 by a into tan inverse of s by a from s to infinity. So a cancels. This is tan inverse of upper limit is, replace s by the upper limit. Infinity by any value, infinity minus tan inverse of, this is s by a. So as it is, replace s by s, that's giving you the same thing. What is tan inverse of infinity? Pi by 2 minus, this is tan inverse of s by a. What is pi minus tan, pi by 2 minus tan inverse of s by a, which is nothing but cot inverse. So cot inverse of s by a. Hence you got the answer of Laplace transform of sin at by t using this property. See one more example you take. Find Laplace transform of 1 minus e power minus at by t. So as per this property, integral from s to infinity f of s. Here what is f of t? F of t equal to 1 minus e power minus at. We need Laplace transform of f of t. What is Laplace transform of 1? 1 by s minus Laplace transform of e power minus at 1 by s plus a. So this gives you s plus a minus s, which is a by s into s plus a. Okay, or else you can substitute directly like this, because that helps to simplify the integral easily. 1 by s minus 1 by s plus a into ds. This is your f of s. That f of s I have substituted here. Now integrate this. What is integral of 1 by x? Log x. So it is log of s minus log of s plus a, natural logarithm. Then from s to infinity. Then I can write this as a log of s by s plus a, from s to infinity. Log m minus log n is log of m by n. Now apply the limit. When you apply the limit for this gives you log of, see, upper limit is limit s tends to infinity log of s by s plus a, minus lower limit is s. So you will get same log of s by s plus a. Upper limit minus lower limit. How to simplify this now? Limit s tends to infinity. We directly apply log of infinity by infinity, indeterminate form you will get. So what you should do is take s common. 1 by s common in the denominator. 1 plus a by s. So this s cancels. You will get then log of 1 by 1 plus a by s. Now when you apply the limit s tends to infinity, what it gives you, this value is infinity, 1 by infinity, this value becomes infinity. This is 0. So log of 1 you will get log of 1 equal to 0. So this term gets simplified to 0, minus this is log of s by s plus a. Okay, so that can be written as this minus is there. Now again log m minus log n property if you apply, then you will get the final answer as log of s plus a divided by s. Taking the reciprocal, then you can remove that negative sign. So final answer is log of s plus a by s. See the next property. If Laplace transform of f of t is f of s, then Laplace transform of this definite integral 0 to t f of t dt is given by f of s divided by s. See the example here. Integral from 0 to t cos a t dt. So you have to find Laplace transform of this integral. So this is your function f of t. So f of t equal to t into cos a t. Okay. First, let us find out Laplace transform of this. Laplace transform of f of t equal to Laplace transform of t power 1 into cos 8. You can apply here the derivative property I told. The second property, you can apply that here. So n equal to 1 and f of s is equal to Laplace transform of this s divided by s square plus a square. So this equal to minus 1 power 1 into first derivative of this. How to find derivative of this with respect to s? Denominator quotient rule into derivative of s is 1 minus numerator into derivative of denominator is 2s divided by s square plus a square whole square. Okay, let us simplify this. After simplifying, here you will get minus 2s square plus s square. That is minus s square. Minus of minus plus. So s square, then you will get minus a square divided by s square plus a square whole square. A square plus a square whole square. So this is equal to here. What is this property? F of s divided by s. So this is your f of s. Substitute here. S square minus a square divided by s square plus a square whole divided by s. So you can write it as multiplied by s here along with this term. This gives you the Laplace transform of, that is Laplace transform of this function which involves the definite integral. See the next one, Laplace transform of derivatives. You can include it under properties of Laplace transform. The previous also, it can be named as Laplace transform of integral. Now we are finding Laplace transform of derivatives. Suppose you have a function f of t and whose Laplace transform is denoted as f of s, then Laplace transform of nth derivative of that function is given by s power n into f of s minus s power n minus 1 into f of 0 minus s power n minus 2 into f dash of 0 and so on up to finally f n minus 1th derivative at 0. See, it is easy to remember all negative signs and s power decreases. Finally, it becomes s to the power 0. Only you have f of s in the first term, then rest all small letter f at 0. Starting from f of 0, then derivative of small letter f at 0 up to n minus 1th derivative. See, for example, if you want to get the first derivative, then Laplace transform of dash of t n equal to 1. So, s into f of s minus f of 0. Okay, because 1 minus 1, 0. It is f of 0. Laplace transform of f double dash of t is s square into f of s minus s into f of 0 minus f dash of 0. Laplace transform of f triple dash of t is s cube into f of s minus s square into f of 0 minus s into f dash of 0 minus f double dash of 0. So write first s cube, s square, s then s power 0. So there is always f of s in the first term, only in the first term. Then write f of 0, f dash of 0, f double dash of 0 like that. Similarly, if you want the fourth derivative, so this is Laplace transform of fourth derivative of the function f is s power 4, s4, s cube, s square, s power 0. So all negative signs. Then write f of s, f of 0, f dash of 0, f double dash of 0, f triple dash of 0. So highest derivative of small letter f is third derivative for this while finding the fourth derivative, Laplace transform of fourth derivative. So this is the formula to find the Laplace transform of derivatives. This is very useful when you are solving the differential equations of an unknown function. Unknown function will be given. You want to find that unknown function in the differential equation. In that case, we apply this formula to find the value of y. So, Laplace transforms are mainly used to solve initial value problems, and Fourier transforms are used to solve boundary value problems. Let us give an example for this property. See example here. Laplace transform of f triple dash of t you have to find out. Function is sine 2t. So you can do either finding first derivative, second derivative, third derivative, but I am now illustrating this using the Laplace transform of derivatives formula. So Laplace transform of f triple dash of t equal to, what is the formula? S cube, then s square, then s, then s power 0, that is 1. So f of s here minus f of 0 minus f dash of 0 minus f double dash of 0, all negative. This is how to remember the formula. Now I want f of 0, f dash of 0, f double dash of 0. So what is f of 0? F of 0 is a sine 0, 0. So what is f dash of t? Derivative of sine 2t is 2 cos 2t. So f dash of 0 equal to 2 cos 0 is 1. Then f double dash of t equal to minus 4 sine 2t. That is because derivative of cos is minus sine. So f double dash of 0 equal to, it is 0 because sine 0 is 0. So I got f double dash of 0, f dash of 0 and f of 0. Next I want f of s. What is f of s? F of s is Laplace transform of sine 2t. What is Laplace transform of sine 2t? 2 divided by s square plus 2 square, which is 4. Therefore substitute all in the formula. So Laplace transform of f triple dash of t, which is equal to s cube into 2 by s square plus 4. Okay, s cube into f of s minus s square into f of 0, which is 0. Okay, minus s into f dash of 0, which is 2, minus f double dash of 0, again 0. So after simplifying, you will get a final answer as Laplace transform of f triple dash of t equal to 2s cube by s square plus 4 minus, this is 0, this also 0, 2s. So which is 2s cube minus 2s cube minus 8s divided by s square plus 4. So this gives you, cancels, minus 8s divided by s square plus 4. Okay, this is how using this formula of Laplace transform of derivatives. Without using formula also you can do, find f of f dash of t, then f double dash of t, f triple dash of t. What is f triple dash of t? So f double dash of t is minus 4 sine 2t. So it is minus 8 cos 2t. So f triple dash of t is minus 8 cos 2t. So as per this, Laplace transform of minus 8 cos 2t is minus 8s divided by s square plus 4. You will get the same answer in both the cases. So that's why I told you this is mainly useful. Laplace transform of derivatives is mainly useful to solve the differential equation. This formula is helpful to solve the differential equation. So these are all different properties of a Laplace transform. See here, now let us solve some problems based on the properties learnt. So we have to show that integral from 0 to infinity t e power minus 2t a sine 4t dt equal to 1 by 25. So it looks like the definition of a Laplace transform. So as per the definition of Laplace transform, integral from 0 to infinity e power minus st, this is f of t into dt. So here Laplace, this is nothing but Laplace transform of t into sine 4t. Now we want e power minus 2t in the question. It is given in the question e power minus 2t. First let us find out this. How to find out Laplace transform of t into sine 4t? The derivative property, not Laplace transform of derivatives. There is one more thing called as derivative property, that is Laplace transform of t power n into f of t, which is equal to minus 1 power n into d nth derivative with respect to s of f of s. Okay, so you make use of this property here. So what is here f of t? F of t is sine 4t. What is Laplace transform of sine 4t? F of s is equal to s 4 divided by s square plus 4 square is 16. This is f of t. T to the power 1. So minus 1 power 1 into first derivative of f of s, 4 by s square plus 16. So let us find it, minus 4 outside, then 1 by s square plus 16, that is minus 1 by s square plus 16 whole square into 2s. That is because derivative of 1 by x is minus 1 by x square. Then the chain rule. So 1 by s square plus 16 derivative minus 1 by s square plus 16 whole square. Then derivative of square is 2s. So minus of minus plus 8s divided by s square plus 16 whole square. So this we got integral value of this equal to 8s by s square plus 16. Now I want t e power minus 2t sine 4t dt. So here s equal to how much? 2. So put s equal to 2. So what happens? 8 into 2 divided by 2 square is 4. 16 plus 4, 20. 20 square. This is equal to 16 by 400. That is nothing but 1 by 25. So first let us make use of the definition of the Laplace transform in terms of s. Then replace s by the required value. Here required value is 2.